Okay, so this is one very interesting problem based on kinematics, motion in 1D. An insect moving along a straight line without returning travels in every second distance equal to the magnitude of time elapsed. So the first challenging part of this question is to understand what it is written. Distance travels in every second, distance is equal to the magnitude of time elapsed. So many students will write like this: distance traveled is equal to magnitude of time elapsed. So if you write this, this is incorrect. It is saying distance travels in every second. Distance is equal to the magnitude of time elapsed. So this is incorrect. X is equal to t. It is saying distance traveled in every second is equal to magnitude of time elapsed. That means, let's say in first second. Okay, let's say in first second. So first second distance traveled is, let's say, 1, because time elapsed is 1. Now in second, so in second time elapsed is 2 seconds, so distance traveled will be 2. In third second time elapsed has been 3 seconds, so now in that second it will travel a distance 3. Similarly in fourth second, how much distance will it travel in fourth second? It will travel 4 meter, because time elapsed is 4 seconds. So this is what it is written here, that travels in every second distance equal to the magnitude of time elapsed. So in tenth second it will travel 10 meter. In 20th second it will travel 20 meter. Okay, and assume acceleration to be constant. Then you have to find the initial velocity and the acceleration. So this is very interesting problem, because the challenging part was to understand the question first. Now how to solve this question? See, there are two ways. First is, let's write this. I will just take a new page. Okay, so let's write distance traveled is, like, in 1 second, first travels 1 meter, then in 2 meter, then in third second 3 meter, then 4 meter, and so on till t. So this is the x is the distance traveled in, total distance traveled in t seconds. So total distance traveled in t seconds. Okay, so now this is sum of n natural numbers, sum of n plus 1 by 2. So this will be n plus 1 by 2. So n plus 1 divided by 2, right? Sum of n natural numbers. So n here is t. So t into t plus 1 by 2 is x. So now you got your answer. X is equal to t square by 2 plus t by 2, right? X is equal to t square by 2 plus t by 2. So differentiate, you will get velocity, right? Velocity is equal to dx by dt. So therefore velocity is equal to 2t by 2 plus 1 by 2. So you got v is equal to 1 by 2 plus t. Now a is constant, compare it with v is equal to u plus at, and here is your answer. V is equal to u plus at. So just see, u is equal to half and acceleration is equal to 1. So you got both the answers correctly, right? So this was an interesting problem. Another approach could be distance traveled in nth second formula. Distance traveled in nth second was u plus a by 2 into 2n minus 1. Distance traveled in nth second. So distance traveled in t second, tth second will be equal to t, because in every second it is traveling a distance equal to the time elapsed. So distance traveled in tth second. Distance traveled in tth second, right? Instead of nth second, tth second is equal to t, as given in the question. So t is equal to u plus a by 2 into 2t minus 1. Distance traveled in tth second is same as t. So now when you solve it, you will have t is equal to u plus at minus a by 2, right? U is equal to at minus a by 2. So u is equal to a by 2 plus t 1 minus a. I guess it's correct. U is equal to a by 2 plus t into 1 minus a. Now see, one interesting approach is there. Here this is the equation, right? U is the initial velocity, a is the acceleration. So u should not depend on time. This is one interesting approach. You can apply in other questions also. U should not change with time, because u is a constant. So if u is a constant, it should not change with time. Then the coefficient of this time should be 0. because if this is not 0, then for different values of t you will get different values of u. Now u is the initial velocity, which should be constant, therefore the coefficient of time should be 0. Understood? Because if it is not 0, then for different time you will have different initial velocity, which is incorrect. So therefore this strategy is 1 minus a should be equal to 0. So that means a is equal to 1 SI units, and initial velocity at time is equal to 0. At time is equal to 0, u is equal to anywhere a by 2 initial velocity, so u is equal to half. So this is also one approach, and this was the easier approach. So thanks, and this was an interesting problem. Hope you enjoyed it. Bye bye.